All right, 8.9c. How do we adjust the rate of an equation? Question mark. So today that's what we're going to be messing with. We are going to change the rate, which is the part inside the parentheses. And the idea is fairly straightforward. Okay, the original equation, says it right here, come on, must be equivalent to the original, and you can check it. Okay, and we are simply going to change it. So if we have 1 over n on the inside, we're going to balance it out with a n on the outside, because 1 over n times n on the outside cancels. Well, I'll show you what I mean when we get into a question here. So, first problem here, if a credit card company charges 13.5% yearly interest, which of the following calculations would be used in the process of calculating the monthly interest rate for any number of years t? So the first thing is that you have to write the yearly formula, which is obnoxious in and of itself. So we have our A equals equation. So A equals the principal, which it did not tell us, times 1 plus the rate, which we divide the 13.5% by 100 to get that. Come on, please write. There we go. So A now equals P times 1.135 to the power t. And that is the equation. That is the yearly equation. The yearly rate is given right here. It is 1.135. But we want the process rate for calculating the monthly interest rate for any number of years t. So which of the following calculations to be used in the process of calculating monthly? And that's what I care about. We have the yearly rate for the number of years, but I would like the monthly rate. So if I want to change, all right, we all know there are 12 months in a year. I need to do a little bit of math here. So that is copy the original. And here's what we're going to do, all right? We are going to take and change the yearly rate by raising to 1/12. Why? Because there are 12 months in a year. But you know the idea of a math problem. Like if I have 2x equals 7, and I want to add, 2x plus 5 equals 7, and I want to balance this equation, but I want to move the 5, I can't just subtract 5 from one side. I have to subtract it from both, right? That balances the equation, subtracting 5 on both sides. Well, I can't do the 1/12 on the left-hand side. That doesn't make any sense because I want to have the A equals. So I'm going to balance it right here. So right here changes it from the yearly rate of 1.135 to the 1/12 now. And then I'm going to change it to the monthly rate by putting the 1/12 and balancing it out. So what could I multiply 1/12 by so that it would cancel and essentially not be there? Well, the answer is pretty easy. It's 1/12 multiplied by 12, which is kind of weird. So if I were to multiply 1/12 by 12, all right, put over 1, I get 12 over 12. It's like it wasn't there. But what it does for me inside the parentheses is it changes this yearly rate that I have in blue, and when I multiply this all out and figure out what this is, that will be my monthly rate. So go to your calculator, you type it on in, or you just trust that I'm doing it correctly. And I have 1.01061. And that's to the power 12t. So now what I have is the monthly rate, 1.01061. I don't know why I can't say that, is the monthly rate in terms of the number of years t. So scroll down. So make sure you label this as the monthly rate. And we're good to go. All right, let's do the next part of it, which is actually much, much easier. So write an equivalent equation using the monthly rate in terms of the number of months. Well, if I want the monthly rate in terms of the number of months, I don't need to have all of this extra stuff that I have up here. It simply just drops. We simply have A equals P. I do need the monthly rate, But if I want the monthly rate in terms of months, then I'm simply just going to have an m for my exponent, because m is months. So what did I really do in this question? Well, I did the exact same thing that I did before. Okay, I'm trying to keep this so we can see it all. You don't need to copy this down, but you do need to have the understanding of it. So what I really had, let me get a different color. So take the original problem, the 1.135. I'm still going to raise to the 1/12th. But now that I'm dealing with the yearly rate being changed to months, I'm going to put an m up here. And I just figure out what 1.135 to the 1/12th is. All right? And since I've balanced it, now essentially what I've really done is I've taken that 12t, right? I've said how many months are in a year. Well, I'm taking that 12 and I'm dividing it by 12, and then I'm adding an m to represent months instead of using t that I have up here to represent years. So when I divide 12 by 12, change the letter to months because we're dealing with it months now, I get just a 1m up here because the 12s cancel. So bottom line, whenever it says monthly rate to the power, or in terms of months, you will just change the rate how you normally would change it, and then stick an m up there for months. And if they wanted the daily rate, you can go from there, the hourly rate, minutes, seconds, all that good jazz. All right, so let's move on to another problem. So here we go, a study of the annual population of red-winged blackbirds in Fort Mill, South Carolina shows the population can be represented by the function, where t represents the number of years since the study began. In terms of the monthly growth rate, the population of red-winged blackbirds can best be approximated by the function. So here we have to go through, and I'm going to go through and do it both ways, just like we did previously. All right, I'm going to figure out the monthly rate with years and the monthly rate in terms of months. So here we have our function, b of t equals 750.16 to the power t. So we go through and read the problem again and find out that this is the annual population where t represents the number of years, so we're assuming this is the yearly growth rate. So I need to change it to the monthly growth rate, and that is the key here. So I want the monthly growth rate. Whoops, that's a little off. So the monthly growth rate means I'm going to multiply by 1/12 to balance it out. All right. I'm going to keep the 12 out here. So the 1/12 and the 12, again, when you were to multiply, a power to a power we've learned is multiply. So when you multiply those two, they would balance and cancel. So my new equation would be 750. The 1.16 being raised to the power of 1/12 is 1.012, and I have to the 12t. Now, that is the monthly rate right here. In terms of the number of years t, so this is years. Now, I haven't looked at the answers to the question, and I'm going to finish solving this out. If I wanted this in terms of the number of months, I would just have b of m for months equals 750. I would have the monthly rate to months m, and that would be that. So which one of those two answers do we see there? Because this is the Regents, and typically looking at the answers before you do your work is more than likely going to throw you off instead of help you. So I don't see any m's over here, so it looks like I didn't need to do the bottom portion in green. 750, 1.012, and you can see they have 1.012 to the power t to the power 12t. All right. Obviously, we don't want the 1.16 because that is still the yearly rate. So the monthly rate is the 1.012, so we can cross off the bottom two. And we want to have the 12t exponent, so it is choice 2. Okay, I want to give you one more example real quick and just copy it down. So let's say I have something in terms of the daily rate. Okay, and this is the daily rate in terms of the number of days d. So we'll label it daily rate, and this is number of days. If I want to convert this to the hourly rate, all right, you have to ask yourself how many hours are there in a day, so we copy it again. Okay. Come on, right. You got it. So, how many hours in a day? Well, there's 24. So I'm going to change this now and do 1 over 24. It's not always 12. And to balance it, I've got to put a 24d up here. Okay? So, figure out what 1.5 to the 1 over 24th is, and I write my new equation. This works out to be 1.017 to the 24d. I now have the hourly rate in terms of d, number of days. If I wanted it to be in terms of the number of hours, I would just write P of H equals, okay, and that would be 50, 1.017 to the H, the number of hours. And the reverse works as well. Let's say I wanted to take this exact equation right here and convert this equation to the daily rate. Well, I would then have to do 24 on the inside. So I'd put 24 here, and then 1/24 on the outside. Works the same way. All right, that's pretty much it. Go ahead and make sure you do the practice. It will not be easy. It definitely will be challenging. Please ask for help. And then do the summary. Take your quiz. Thank you.